So hello everyone, I'm Zhuozhao. So I was a postdoc in Globus Lab for 3 years, and now I'm an assistant professor at Southern University of Science and Technology. So today, I'm going to talk about how we the Parsl and funcX team try to enable programming distributed data flows with Parsl and funcX. So since this is an ongoing and very early research work, so I'm going to talk about what we have right now and what we aim finally, and we would like to hear from everyone about your thoughts. So nowadays, many data flows are increasingly complex and distributed. For example, they often consist of dependency-based tasks. And also with the phenomenon growth of data volumes and velocities, today's data flows also have some distributed compute and data requirements across multiple computing resources. So this often made us think about how to actually improve Parsl and funcX to accommodate these distributed data flows. So just a quick recap here, as Kyle has already introduced. Parsl is a flexible library that enables one to use the decorators to compose a data flow and express the parallelism. And actually, when we were working on Parsl, we have been requested many times from the users about how we can use Parsl to run their data flows on single or remote or multiple remote resources.
Really? Yeah, I'd be like, do you speak English?
What happened?
Just someone was unmuted. I muted them, Zhuozhao. Carry on.
Okay. So we were requested by many users about how we can use Parsl to run their data flows on single and multiple remote resources. But this remote execution is actually a bit tricky under the Parsl execution model. Just like Kyle already mentioned, primarily due to the complicated internet connection, as well as the complicated authentication methods, such as the two-factor authentication, especially on multiple different resources. And on the other hand, funcX is actually a federated resource, a federated function as a service platform. So you can essentially deploy the funcX endpoints software on anywhere that can run Python and turn it into a function serving endpoint. And then the funcX endpoints will connect to our centralized service to receive tasks. So you can submit functions via the centralized service and execute them on the remote endpoints. So this connect out pattern in the funcX endpoint actually solve the complicated network and authentication problems. So you would think funcX is actually a perfect executor candidate in Parsl that allows one to run their data flows on multiple sites. So we explore to combine Parsl and funcX to enable the distributed data flows, where the Parsl serves as the uniform programming interface to program your data flow, and funcX serves as the execution engine for the data flow. So to do so, we have implemented a prototype funcX executor for Parsl. So this is a very simple code snippet of the funcX executor in Parsl. And unlike, can you hear me? It looks like my internet.
Yeah, I can hear you just fine.
Okay, good. So unlike other executors in Parsl that you need to specify the number of workers, in funcX executor, you just need to specify a list of the endpoint UUIDs to execute your data flows. And all the environments configurations, such as the number of nodes, cost per worker, are on the funcX endpoint side. So you need to configure on the funcX endpoint side to appropriate request resource. And with this executor for Parsl, we were able to easily compose a data flow using the Parsl simple decorator interface and distribute the task to different funcX endpoints. However, there are still some ongoing work to make it more usable. So for example, the first thing we need to work on is to add a layer to transparently distribute tasks to specific endpoints. So currently, we allow task distribution manually set by using two approaches. So the first one is via the decorators in Parsl. So in Parsl, the decorators has a keyword argument called Parsl resource specification. So one can specify a set of funcX endpoints to send this full function to. And the other one is on task invocations, where you can specify, again, the same endpoint, a list of endpoint with the same Parsl reserved keyword arguments. So of course, this task distribution mechanism is totally manual. So we will expect that the combination of Parsl and funcX should distribute tasks to endpoint transparently and automatically without the knowledge from without too much knowledge from the users. So in other words, it should be able to automatically send a task to the most appropriate location, such as where the data is located, where there are available resources, or where the compute is the fastest. So to achieve this intelligent distribution layer, there are still some improvement or feature requests we are still working on. You're right, I'm still requesting feature, even I'm on the funcX team. So for example, we need funcX to be able to return the current status of an endpoint, such as its liveness, available workers, wartime, or queue length, and so on. And actually, we have the funcX SDK already provide an interface to fetch this endpoint status to some extent, but we need to make this report more comprehensive. And the other part is the task status report, such as the task utilization and task completion time. So we need this information to intelligently decide where to send a task. However, we find that it's extremely challenging to report and monitor task status across distributed endpoints and also at scale. So I believe the team is currently exploring how to do this task status report efficiently. But if you know of any good monitoring approaches or tools that are suitable for funcX execution model, please also let us know. Besides task distribution, one important component is to manage the data properly across endpoint for the data flows. I believe this is also mentioned by Eric. So I hopefully in the future we can have a data management plan to handle the case where the input and output are so big. But since we are targeting a distributed scenario, so we need to support, in this case, both the inter-endpoint transfers and intra-endpoint transfers. For the inter-endpoint transfers, there are actually many available tools to use, such as Globus. So for the intra-endpoint transfers, many computing resources already have their shared file system. So that's a good source for the intra-endpoint transfer. But for some other latency sensitive data flows, we need a better data store than the shared file system. So this inspired us to incorporate some in-memory store to the funcX endpoint to improve the data transfer performance. So we are working intensively to incorporate all these data transfer or data store technologies into funcX and to enable data management to be fully transparent to the users. So again, Glenn just asked a question about the environment management across multiple endpoints. And actually, this is also one challenge in this distributed data flow framework. So actually, it's quite hard to manage the runtime environments for different functions across different computing resources. And actually, we have a prior work that calls Lightweight Function Monitor. This work was published on IPDPS 2021, and this is a collaborative work with Doug's group from Notre Dame. I believe he's going to talk about this in more detail tomorrow. But basically, this work presents a method to automatically detect the dependencies of functions and then package a conda environments and then distribute the environments to the workers. So that's one alternative approach. And there's another alternative approach is to use the popular container technology in this case. So in this case, we need a container service to dynamically build containers for funcX functions for different endpoints. For example, we need to build Docker container, we need to build Singularity container. And by using this container service, users can just input their dependency, the function dependency, and then we can automatically build that for your funcX endpoints. So together, this is an overall architecture of the Parsl and funcX framework we are working on right now. So we have the Parsl and funcX as the foundation here, and we are working on 3 more layers to fulfill this framework. So including the task distribution, environment management, and also data management. So in summary, via this framework, we aim to enable one to easily compose a data flow on local machines and then compute purely on remote machines. And they can easily pull their data flows to anywhere with the funcX endpoint. So in addition, we expect this framework to enable the potential to break down a large data flow and use distributed computing flows, use distributed computing resources to avoid the high queuing time of large jobs when possible. So that's all I have, and thank you for your attention. So we really appreciate if you can give us some suggestions and tell us any potential use case for this framework.
Cool, thanks. Does anyone have any questions?
I guess one thing maybe I should preface that talk late. Sorry, everyone. I think Zhuozhao was a postdoc with us, and he's just left to become a faculty member in China. So Zhuozhao has been at the sort of cutting edge of the research and development work on funcX, and a lot of what he was speaking about there are sort of up and coming things that we are working on a research sort of space. Some of those things will become real, some of them might not become real, but the idea, the thought with the presentation was to generate some ideas and for people to provide feedback on some of the stuff we're working on there. Yeah. Key ones being an executor interface where Parsl can speak to funcX, an endpoint management layer where we can do sort of more distributed execution, and then a data management fabric that might span things from sort of Python objects through to files with Globus.
Yep.
Over to you, Ben, for questions.
Cool. So I'll just comment that one thing that I think is especially interesting for this is getting some decent multi-site support for Parsl, which has been a thorn in my side for a very long time, and on Swift before it. So no one's posted any questions, so we'll move on to the break.
I have a question.
Go.
So this may not be particularly relevant to this particular talk, but I just wanted to better understand how funcX would work with a scheduler on a typical compute cluster. For instance, you need to first submit a job to plant a function in there, right? And then you need to call that function from that compute node. Is that the way it works?
Yeah, the funcX backend is using the Parsl's provider and executor interface. So it's using the pilot job model. So you first request a job and then spawn some workers and then send the functions to those workers.
Okay, so does that mean that funcX, so can I work on funcX independently of Parsl or no?
Yes.
So it's possible to install a funcX on a compute node and call it outside of Parsl, right?
Yeah.
Okay.
That's really the only way right now. The Parsl funcX integration is very prototype, and so the number of users that have used that is about 1, Zhuozhao, but we're hoping that number to increase. So as Zhuozhao said, the funcX endpoint basically provisions infrastructure using Parsl. So you can configure it in terms of how it provisions infrastructure. Should it go and grab a bunch of nodes when you start the endpoint? Should it sit there and wait until there's some workload before it grabs nodes? Should it release nodes immediately, or should it keep them for a while after workloads run? So there's a lot of flexibility there, and it's all using the Parsl configuration model for how it grabs nodes from a cluster.
Got you. Thanks.
Cool. Okay,
Yeah.
10 seconds.
I have a quick question, if
Yep,
possible.
go. Yep, go.
Yeah, just about the funcX service, and very nice talk, Zhuozhao. On the service, are you imagining that to be more centralized service, or when you have different people, deploying different funcX services, you're gonna make them know each other, especially when you talk about data management, And for example, if you are doing these things, we were talking before about the cross facilities. So do you want one service to talk to another, know which data is around, and knowing how you're gonna move things around or make it available?
So I can probably take this. So our hope is very much to have a single funcX service in the sky and have lots of endpoints that are managed by different people. The advantage being that by having a central service, it's a single place where people register functions. It's a single place where people register endpoints. So it gives you complete sort of control of that whole ecosystem. It's a single service that then manages that reliable execution. We can make sure the security models are all in place, et cetera, et cetera. So it provides, I think, a better user experience. And ultimately, I think our goals for funcX are really around usability. And as Eric put so well, sort of trying to make it easy for people to use distributed and remote infrastructure. So that's very much the model. How that ties in with data is going to be interesting in that there's an analogous service, Globus, for managing wide area data transfer that obviously is a very natural companion to funcX in terms of how we leverage that. But then there's probably also another level of data management, like on node or across a single system, where we're doing some prototyping work around a data fabric there, but we haven't done much. And if you're interested, we'd love to have a bigger team effort, start thinking about what a data fabric for this type of federated FAS model looks like. I think a great opportunity for writing some papers as well.